Bismillahirrahmanirrahim. Chapter 2 in algebra is about polynomial functions. Polynomials and polynomial functions. We have talked about what a polynomial function is before. Here I'll just give you an example. Y equals 5x to the 6th minus 4x to the 5th minus 3x squared minus plus 5. That's an example of a polynomial function, where the variables are raised to different degrees over here like this. But we should start gradually, and first thing we should learn is about how we some of the properties of exponents, because polynomials have exponents variables. We need to learn how to deal with them. So the first thing we're going to talk about is some properties of exponents. Okay, properties of exponents, or some rules basically. In other words, how do we deal with exponents? Okay, when we say x squared, okay, we mean x times x, right? When we say x cubed, that means we multiply x by itself 3 times. In the same manner, x to the 5th would be x times x times x times x times x, like that. And when we say x to the cubed times x to the 4th, for example, you can write this long way. This is x times x times x, that's that, and x times x times x times x, that's this. So altogether we have x to the 7th, don't we? So this gives our first rule, and the rule is this: a, which is a real number or variable, a to the m times a to the n equals a to the m times a to the n equals a to the m plus n. So that's our first rule. Okay, so this is our first rule. This is called product of powers. Okay, product of powers, product of power, product of powers rule or property. Okay, so that's our first rule. A to the m times a to the n equals a to the m plus n. Okay, let's do some examples with this to make sure we get it. So let's say x to the 5th times 3x to the 4th. Now you understand there's a invisible one, so to speak. This is 1x to the 5th times 3x to the 4th. So this is just going to be 1 times 3, which is 3. X to the 5th times x to the 4th, that's like x to x, 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 and that's x, 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 x. Altogether, we have x to the 9th. There are 9 of them, which is this rule over here. A to the m times a to the n equals a to the m plus n. Okay? So let's do another example. I have 2x to the 4th times 5x to the 2nd. Okay? Now this is going to be what? 10x to the 6th. 2 times 5 is 10x to the 6th. Okay, let's do this one. Minus 3x times, this is a multiplication sign, or we can make the parentheses to be clear. 4x cubed. How about this one? Very good. So this is going to be negative 12x to the 4th. Correct? 3, that's negative 12. There's one of them here, and 3 of them here, so that's this. Negative 12x to the 4th. Now, so that's this rule. A to the m times a to the n equals a to the m plus n. Okay, you gotta know this. Now this can be like this. For example, 3 squared times 3 to the 5th. Well, that's 3 to the 7th. Same thing. Okay, And negative 2 cubed times negative 2 to the 8th is negative 2 to the 11th. Right? As long as the base here is the same, you can apply this rule. Okay, that's our first property or first rule. And there's this rule. Let me give you an example. X cubed, that's x cubed, to the exponent of squared. So this is x cubed squared, the whole thing squared. Well, this means x cubed times x cubed. Okay? So now this means that 3 of these. All right, this is x to the 6th. Now let me give another example. X cubed to cubed. Now this means you take x cubed 3 times, like this. Okay, so that's going to be x to the, there's 9 of them, right? X to the 9th. Now we can summarize this as a rule, see? A to the m to the n equals a to the m times n. So that's another rule. Okay. Alright. So let me rewrite this. So these are the rules that we have learned. A to the m times a to the n is a to the m plus n. A to the m to the power n is a to the m times n, like this. A to the m times a to the n is a to the m plus n. A to the m to the n is this, a to the m times n. This is called product of power rule. Product of power rule. This is called power of power rule. Interesting, right? Power of power. Power of power. Power of power rule. Product of power rule. Product of powers rule. Power of power. So let's do this, a couple examples like this. So if x to the 5th to the 3rd, this would be x to the 15th. Very good. Okay. How about 3 squared to the 10? Same thing. 3 to the 20th, like that. Okay. So those are the two rules that we have learned so far. Let me enumerate them to you again until you kind of know them really well. Okay. And then there's the third rule here. Now, look at this. X cubed times y squared. Now that's the exponent of 3. Now see here, these are different, right? I didn't say x cubed times x squared, something like that, right? Right? These are different variables, different entities. Now this is kind of like the distributive property for exponents, okay? So the way this works out is, this is going to be x to the 3 times 3 is 9, okay? And 3 times 2 is 6, okay? The way this works out first, let me just, in 2 steps, okay? Go from here to, you distribute this, so you get x cubed, and then y squared, cubed, okay? And from the power of the power rule, that's this one, we get x to the 9th, and power of the power y to the 6th, which is that. You follow? You have to be careful with this one, okay, like this. Negative 2 x cubed, okay, 2 squared. Let's do that one. Now this 2, you have to remember, you distribute both to the 2 and the x. So common mistake for us to would be negative 2x to the 6th. So that would be very wrong. Okay? The reason is because the 2 is distributed to both. So it's negative 2 squared and x cubed squared. So negative 2 times negative 2 is 4x to the 6th. Okay? How about this one? Negative 2x cubed cubed. See the same thing here. You distribute the 3 both to the negative 2 and the x. So this becomes negative 2 cubed times x cubed cubed. Now negative 2 cubed, be careful, is negative 8. Okay, because it's negative 2 times negative 2 times negative 2. Right? It's negative 8. And x cubed cubed is x to the 9th. Okay? So this is a third rule. Okay? Now let's enumerate the rules again. A to the m times a to the n, this is the product of powers, is a to the m plus n, and then we have a to the m to the n, this is the power of a power, that's a to the m times n, and then we had a times b to the m. Now they're two different things. This is kind of like the distributive property, so to speak, of the powers. This is a to the m times b to the m. Okay? So this rule is called power of product. Power of a product. I think it's more important that you understand these rules, okay? Like this. You should be able to write these down. Okay. So so we have done this so far. Okay. There's not that many, don't worry. Only 10 more. No, I'm just kidding, there's 3. Only 3 more, I think. Alright. Here's this one. X to the negative 3. What does negative exponent mean? Okay. Negative exponent means that this exponent belongs in the denominator. That's what that means. You flip it to the side. So when it's negative exponent like this, you rewrite it, or you can rewrite it as 1 over x to the 3, like this. Or if it's like the other way, 1 over x to the negative 4, negative exponent means it kind of doesn't belong here. It wants to go on the other side. If it's a numerator, it goes to go to denominator. If it's a denominator, it goes to numerator. So this becomes x to the 4th. Okay. So this is a rule regarding negative exponents. So how do you deal with negative exponents? So the rule can be written as this, okay? A to the negative m, here is suggesting m is it's negative m right here, is 1 over a to the m. Okay? So that's the negative exponent rule. Now watch. Let's do some examples. If I have x to the negative 5 y cubed. Okay, now the negative exponent here is only to the x, so this will become y cubed over x to the 5th. See? That's it. Okay, now look at this one. Negative 2x to the negative 3. Now you be careful here, because the negative 3 exponent is for the entire expression here. So the whole thing will go to the denominator. So it'll be 1 over negative 2x cubed. Now don't be taking it to my denominator and putting that negative right back. Right? Oh, then you've done nothing, right? When the negative exponent goes to the other side, it becomes positive. Now you can simplify this, see? Negative 2 cubed times x cubed. This is the distributive property, so to speak. That becomes 1 over negative 8x cubed. Now this negative 8 can be written here or here. This, if it's like this, you can just rewrite it as 1 over x to the 1 over 8x cubed, like this. Okay, this negative can be written either up here or down here. Okay? Alright. So, now, I just for emphasis, negative 3x to the negative 4, y to the negative 3, over z to the negative 2. Okay? Now look at this one. Here, there's a lot of negatives. Okay? The 3 stays up. It has, don't mess with that because there's no negatives up there. So there's no negative exponent of 3. So that negative 3 stays as a numerator. Now this x goes to the denominator, x to the 4th. And y also goes to the denominator because also negative. Now z is a negative 2. It goes to the numerator. So that's going to be z squared. Okay? So, what have we learned so far? Okay, let's... a to the m times a to the n is a to the m plus n. And then a to the m to the n is a to the m times n. Now, listen, I'm writing these, right? You know how many times I've written this for students? Lots of time. I don't tire of it because I know how important it is for you to know this, and I would request you to really don't tire of these. Just you should be able to write this on your own. In other words, you should do it well enough that you can write these rules like this, like I'm doing. Like this, a times b to the quantity to the power n is this. That's the distributive property. A to the negative m is 1 over a to the m. Okay? Now, there's another rule that's like this. It is a corollary to this. If you have a fraction like this, a over b to the m, you can distribute this also like this. That becomes a to the m over b to the m. See? No difference. So it's like, for example, x cubed over y squared, all of this to the power of 4. This becomes x to the 12 and y to the 8th because you distribute the 4 over to both. Okay? That's a over b to the m equals a to the m over b to the m, like that. Alright? Now, fair enough. Now, there's one rule here, easy one. That's good, it's the easy one. A to the 0, 1. Anything to the power of 0 is 1. If I have like 3x to the 5th, y to the negative 8, and z to the 16, all of this to the power of 0, that equals 1. Okay? Now, look at this one. 3x squared, y to the 0, z to the 5th. This becomes 3x squared, y to the 0 is just 1, z to the 5th. Okay? Alright. Now, here's the second to the last. This is the last rule, actually. This rule is like this. A to the m over a to the n is a to the m minus n. Okay, that's this rule, okay. This is x to the 5th over x squared is x to the 5 minus 2, which is x to the 3. Now, the way I think about this is like there are 5 x's on the top, and there's going to be 2 on the bottom, and you can divide them like this. 2 of them go here, and only 3 left over here. So you kind of like subtract them, right, so to speak. Right? So let's just do another one of them. So you have 8x to the 4th, y to the 5th, okay, and z, okay, and then over here x squared, y, and z to the negative 3. Okay, I'm going to put a 2 over here. We're going to simplify this. I'm going to simplify that. So, well, let's simplify it. Okay, I can do that. Well, 8 divided by 2. 2 goes in there 1 time, 2 goes in there 4 times. Okay, that's a 4. Not too bad. X to the 4th divided by x to the 2nd. Well, there are 4 of them here. It's like this. And there's 2 of them on the bottom over here. 2 will be left, right? Or x to the 4th minus 2 to minus 2 x squared. From this rule, a to the m over a to the n is a to the m minus n. Like that. Okay? So anyway, there's 4 on the top, there's 2 on the top, quadratic chop over there, then you get x squared. And regarding the y's, there's 5 on the top, there's 1 on the bottom, see? That becomes y to the 4th. Now look at the z's. There's 1 on the top, there's negative 3 on the bottom. Okay, just do it in baby steps over here. Okay, so z to the 1st, bring the z up, z to the 3rd it becomes. There's nothing left on the bottom except for 1. Okay, so this simplifies to 4x squared, y to the 4th, and z to the 4. Okay, so that would be the simplified answer to this. Okay, so that's it. So now I'm going to just write the rules for one last time for your edification, inshallah. So a to the n times a to the n is a to the m plus n. A to the m to the n is a to the m times n, right? And then you have ab to the m is a to the m times b to the m. Okay, and then we have a to the negative m, negative exponent, 1 over a to the m. Fair enough. And then we have a to the 0 equals a big whopping 1. This is always usually very helpful and welcomed. Okay, and then we have a to the m over a to the n. This is a to the m minus n. Okay, and finally we talked about a over b to the m. This is going to be, like, again, distribute this. Okay, you get a to the m over b to the m, like that. So these are properties of exponents. Don't leave home without them. You got to know them, okay? So do yourself a favor, write this down however many times you have to get them memorized 100%, because you really need to know them, inshallah. And the next time we'll do some more complicated examples and fun examples, inshallah. Until then, as-salatu wassalamu ala rasulillah, alhamdulillahi rabbil alameen, assalamu alaikum.